minus x3 and C1 is x3. So x1 minus x2 plus x3 minus x3. That cancels. So what you have is V, that is x1, x2, x3 is equal to C1 V1 here from here. C1 is x3 V1 plus C2 is x2 minus x3 V2 plus C3 is x1 minus x2 minus x2 V3 by star. Okay, so what is TV? That's the formula we want to know. Is x3 TV1 plus x2 minus x3 TV2 plus x1 minus x2 TV3. Now you're given these things, TV1, TV2, TV3. You see, you're given that. So now it's very easy. X3, TV1 is what? TV1 is 1, 0 plus x2 minus x3. TV2 is 2 minus 1 plus x1 minus x2. TV3 is 4, 3. 4, 3. Okay, you are done. So that is, take the coordinates. There are only two coordinates. First one is x3 plus 2x2 minus 2x3 plus 4x1 minus 4x2, comma, second coordinate, x3 times 0 out, minus x2 plus x3 plus 3x1 minus 3x2. So that is equal to what? 4x1 minus 2x2 minus x3, comma, 3x1 minus 4x2 plus x3. Okay, that's the formula. And then what was the question? Final, see, find the formula for this. Find the formula for this. Use that formula to compute this. So answer is T of x1, x2, x3 is exactly what I just found out. 4x1 minus 2x2 minus x3, comma, 3x1 minus 4x2 plus x3. And what is it that I wanted to find out? T of 2 minus 3, 5. 2 minus 3, 5. So that is absolutely routine. Just plug in the values. So 4 times 2, 8. Minus 2 times minus 3 plus 6 minus 5, comma, 3x1, 3 to 6, plus 12 plus 5. So that is equal to 9, 23. That's it. Let's take 2 more problems like this, and that's it. Then you are all set. This is exactly there is nothing to trick on the exam on this question. The problems will be exactly like this. So I took a problem from, this was a problem from R3 to R2. Let's take a problem from R2 to R2. This was problem 1. Problem 2. So exactly the question will come like this. Consider, so this is from R2 to R2. Consider the basis as V1, V2 for R2, where V1 is 1, 1 and V2 is 1, 0. And let T from R2 to R2 be the linear operator. This is actually linear operator, be the linear, because it is R2 to R2. For which TV1 is 1, -2 and TV2 is -4, 1. Find a formula for T of x1, x2 and use that formula to find T of 5 minus 3. Okay. So, okay. So, let V be x1, x2 in R2. So V is C is x1, x2, no? No. What? How did I do? Yeah, x1, x2. That's right. See? Yeah. Okay, good. And V1 and V2 are the two bases. Good. So V is C1, V1 plus C2, V2. So x1, x2 is C1. What is V1? V1 is 1, 1 plus C2. What is V2? 1, 0. So that is C1 plus C2, C1. So x1 is C1 plus C2. x2 is C1. So this implies C2 is x1 minus C1, that is x1 minus x2. Okay, hence, so V, that is x1, x2 is C1 is x2 V1 plus C2 is x1 minus x2, V2. So TV is x2 is a scalar, x2 goes out, TV1 plus x1 minus x2 is a scalar, TV2. Okay, now you know what is TV1. What is TV1? 1, minus 2. 1, minus 2 plus x1 minus x2. TV2. What is TV2?
1, 0.
No. That is V2. V2 is 1, 0. TV2 is here. This
Oh,
is T
minus
one.
4, 1.
Yeah, minus 4, 1. Good. Minus 4, 1. So that is equal to x2 minus 4x1 plus 4x2, comma, minus 2x2 plus x1 minus x2. So that is 5x2 minus 4x1, comma, x1 minus 3x2. And this is how you will write. So T of x1, x2 is 5x2. This is the first part of your answer. So now, so that's the first part of your answer. And then they're saying, find a formula for, so this is your formula. Find a formula for T of x1, x2. This is your formula. And use that formula to find T of 5 comma minus 3. So T of 5 comma minus 3 is minus 15 minus 20, x1 is 5 plus 9, that is minus 35, 40. This is the second part. This is so standard that I have nothing more to say. This is absolutely standard. So I did want R3 to R2. So let me now take a next one. This one was R2 to R2. Let me take an R3 to R3. And then I mean, I'm actually spoon feeding you, but it should be all okay, all set. Problem 3. Exactly, because this is it's absolutely standard. There cannot be any variation here. So I'm really giving you, here it is, take it like that. Consider.
So we're going to get one of these questions like exactly same.
No, not exactly same. Who asked that question? Let's see. Let me catch her. Who asked that question?
No, this is Shania. Shania.
Exactly the same. Well, it will be like this. Will be exactly similar. Yes, exactly similar. Consider the basis S. Yeah, as I was just telling you that there is no variation in this kind of a problem.
You just change the numbers, that's it.
Really? Okay, then I will make it difficult.
No, please no.
Okay, guys, do you want the what? Let's talk. We will talk about the final. Let's finish this first. Consider the basis this for R3, where V1, V2, V3 are vectors in R3. This is the basis. V1 is 1, 1, 1. V2 is 1, 1, 0. V3 is 1, 0, 0. And let T from R3 to R3 be the linear operator for which T of V1 is 2 minus 1, 4. TV2 301 and TV3 minus 151. Find a formula for T of x1, x2, x3 and use that formula to find T of 2, 4, minus 1. You see, that's what I'm saying. There is no variation in this kind of problems. This is straight, standard. It's like I'm just giving you a problem. You take it. Here is a free problem for you. Like that. Oh. That should answer Shania's question.
Thank you.
Okay. So V is x1, x2, x3. V1, V2, V3, the basis. So that is C1, V1 plus C2, V2 plus C3, V3. So x1, x2, x3 is C1. V1, let's see. V1 is 1, 1, 1 plus C2. V2 is 1, 1, 0 plus C3. V3 is 1, 0, 0. So x1 is C1 plus C2 plus C3. x2 is C1 plus C2. x3 is C3. Okay. Just a minute. X1 is C1 plus C2 plus C3. X2 is C1 plus C2. Right. X3 is C1. Oh, X3 is C1. Hi. X3 is C1. That's a typo. Bad typo. X3 is C1. Now I'm happy. X3 is C1. C1 plus C2 times 0. You see my chalk. C1 times 1. C1 times 1. That is C1. C1 times 1. Then C2 times 0. That's C3 times 0. So that's also correct. Okay, so from here, C2 is x3 minus C1, and C1 is x3. X2 minus C1, C1 is x3. And so C1 and C2 I got. C3 is x1 minus C1 minus C2. That is x1 minus x3 minus C2 is x2 minus x3. So that is x1 minus x3 minus x2 plus x3. Okay, that is my C3. So x1, x2, x3 is C1, V1. C1 is, where is my C1? Where is C1? C1 is x3, x3, V1 plus C2, V2 here from here by star. C2, V2. C2 is x2 minus x3, V2 plus C3, V3. C3 is x1 minus x2, V3. Okay, so T of x1, x2, x3 is equal to x3 dv1 plus x2 minus x3 dv2 plus x1 minus x2 times dv3. So that is x3 dv1. Oh, dv1, what is dv1? dv1 is 2 minus 1, 4. 2 minus 1, 4 plus x2 minus x3. dv2 is 301.
301.
Yeah, 301 plus x1 minus x2. dv3 is minus 151, minus 151. Okay, so what does that give you? That is equal to 2x3, take the three coordinates separately, right? 2x3 plus 3x2 minus 3x3. You know how it is happening, right? 2x3 plus 3 times x2 minus x3 plus minus 1 times x1 minus x2, like this. So plus x2 minus x1. This is the first coordinate. Next, minus x3 plus x2 minus x3 times 0, that is out, plus 5x1 minus 5x2. And then finally 4x3 plus x2 minus x3 plus x1 minus x2. So that is equal to, so let's see, minus x1 plus 4x2 minus x3, comma, 5x1 minus 5x2 minus x3, comma, x1, this cancels, plus 4x3, 4x3 minus x3, sorry, plus 3x3. So the first part of your answer therefore is, so let's see, and what do you want to find? T of 2, 4 minus 1. So T of 2, 4 minus 1 will be minus 2 plus 16 minus 1 plus 1. 10 minus 20 minus 1 plus 1. 2 minus 3. So that is 17 minus 2, 15. Minus 9 minus 1. Answer. This is how you will write. 2t of x1, x2, x3 is equal to minus x1 plus 4x2 minus x3, 5x1 minus 5x2 minus x3, x1 plus 3x3, and 2 t of 2, 4 minus 1 is 15 minus 9 minus 1. Okay, that's it. Okay, that is the end of the material. Now, so that's basically it. Now you see, tomorrow I'm going to give you the review. So So from linear transformations, you will get either theorem 1 or theorem 2. And one problem, exactly like this. Going back to Shania's question, right? Exactly like this. Exactly similar. Got it?
Yes.
And tomorrow, yeah. So on the exam, I think there will be, it's a 2 hours exam. Just a minute, wait. Because I want to tell you something from the exam. That's very important about the exam. Wait. Yeah, let's settle this first. This is very important. So wait, let me. So the final exam, we have to decide something here. Math 231 is 17th December. It's a Thursday. It is from 1:45 p.m. to 3:45 p.m. Now wait, let's check it again. 17th December, Thursday, 1:45 p.m. to 3:45 p.m. Very good. Now sign out. I was on CUNY first, actually. Okay, now you see, so you know what's going on. What was we have been having that problem with when I send the email, you'll take a little time to get the exam. That is why I will advise, please come. All students should come at 1:30 p.m. I will give you the exam at 1:30 p.m. And if you get it within 5 minutes, start right away. If you get it within 10 minutes, start right away. But what we have found is that maximum there is a 7 minutes time lag. So for your advantage, come at 1:30 p.m. All of you, please come at 1:30 p.m. Now, the exam ends at 3:45 p.m. I will not give you any extra time, but you will submit the exam by 4 p.m. Exams to be submitted by 4 p.m. on. Okay, I think, and I'm going to give you a review tomorrow. Wait, tomorrow is our review, yes. But give me a little time. Tonight I will actually decide what I am going to, yes, or one theorem. Good. I think there will be 8 questions. How many questions do you want? 8 or 10 or 12?
No. Five.
Five questions.
5 questions. No, this is the final exam. You think it's a quiz or what? That's why I gave you only 4 questions on exam 2, just to make your life easy. Now I want to make your life hard. Why?
Professor,
Because this will be a holiday gift. So if I give you an easy exam, students will say that I insulted them.
Professor, I have an exam 15 minutes after your exam, so can you not make it that crazy? Please.
Crazy. What is that exam, Lindita? What is your exam? Let's see. After
It's
15 minutes?
It's 220. It's for discrete structures.
220. That's very easy.
No, it's not. It's so hard.
It's extremely easy.
To you.
You're going to get a straight A, I guess.
Okay, I hope so.
Okay. Okay, so I think I just 8 problems, 8 questions.
Thank you.
What is that noise coming? Excuse me.
It's from me, from the outside. Car.
Oh, sorry. Okay. So I think there will be actually 8 questions. So one will be one problem.
Professor, you said is like 2 of the questions take like 30 minutes each for me. Like I do 1 hour just to solve the question 1 and question 4.
Oh, one problem on Gram-Schmidt. Then you have to work fast.
Yeah, if I mess anything,
One
I
problem
get
on
lost.
Gram-Schmidt orthonormalization.
No, you said orthogonal for the final, orthonormal for the exam too.
No. Orthogonal is easy. Once you orthogonalize it, it's so easy to make it orthonormal. Come on.
But we did
Professor, you said
orthonormal
it.
one.
You said orthogonal for final, orthonormal.
I said that R3, R2, I will give you R3 for exam 2, and on the final it will be some integral kind of thing. Okay, now wait. Do you want to diagonalize something? Hello?
No, please no.
Oh no.
Oh no. Okay.
It's so
fine.
easy to make mistakes on that problem.
Really? Okay. So but this would be standard. One problem. So this is one. This is one problem. To find the eigenvalues and eigenvectors. That is important. So you don't have to find P inverse AP and all that. Find the eigenvalues. This is standard. Eigenvectors of and I will give you a 3 by 3 matrix. Okay. 2 questions on our topic today. 2 questions on linear transformation. So you have 1 plus 1, 4. Okay. Yeah. Okay. And then there will be, I'm going to review this tomorrow again. So there were some theorems that I did on eigenvalues, eigenvectors. So I will discuss them tomorrow. So let's see how many questions? So 4. One question on, so this will be problem. One problem, but they will be discussed tomorrow, and I will discuss 3. I discussed them tomorrow. I did discuss on 3rd November and 5th November, but I will repeat them tomorrow and I will ask only one of them. Problem on eigenvalues and eigenvectors. And then straightforward things. So how many questions so far? 4, 1 plus 1, 2. So this is 2. 4, this is 1, 5. And then, one simple question. Here, if you know the definition of orthogonal matrix, that's enough. This is a very simple problem I will ask you on orthogonal matrix. And then that's it. And then 2 questions. 2 questions. Fun. That's your holiday fun. Now, what you may ask me, where is it coming from? The holiday fund question? Okay. So, you really do not have to prepare anything. Inner product space, linear transformation. If you have
So the ones that are like if it's linearly independent or not. those
no, if you want, I can go on and putting extra. Do you want?
No, but those are like small questions, easy to solve.
Oh, easy to solve. Okay, but these are very easy questions actually. These are easier. For orthogonal matrix, it's the question that I'm going to put is absolutely easy. All you need to know is the definition of orthogonal matrix. That's it. And no theorems. I will not ask you. And there is a question on problem on eigenvalues, eigenvectors, which I will discuss then. Wait, actually, let me wait a second. Wait a second. I think I have it here. I think I can just to make your life easy so that tomorrow we can finish quickly. I can discuss it. No, wait. Where is it? Where is it? Here. Okay, wait. Wait, friends, wait. I will tell you. Math 231. No, this is going too far. Math 231. Okay. 3rd November. Let me take a look at this. 3rd November. Yeah, 5th November. How come? Okay. No, that's not. No, November 3. Let's see. Okay. Good. So let us discuss this. Hey. Okay. So I have time for this. So I'm going to finish this one. Any one of the following 3 questions. And I will make the choice. You don't have to do it, right? Number 1. If A is a square matrix, show that A and A transpose have the same eigenvalues.
So is this question 9?
No, so this is no, this is not question 9. No, this is related to this star. Related to the, I told you, one question on eigenvalues, eigenvectors. One question I should write. Yeah, this is real. So what kind of a question? That's what I'm answering. Any one of the following 3 questions. So that A and A transpose have the same eigenvalues. You must remember that this is same eigenvalues. I told you that I'm going to put this on the quiz or something like that. Same eigenvalues. Okay. So let's do this. So the characteristic equation for A is determinant A minus lambda I is 0. Now, A minus lambda I transpose is A transpose minus lambda I transpose, that is equal to A transpose minus lambda I transpose, that is A transpose minus lambda I, because I transpose is I. Hence, determinant of A minus lambda I is equal to determinant of A minus lambda I transpose is equal to determinant A transpose minus lambda I. So A and A transpose have the same have the same characteristic equations. And hence have the same eigenvalues. Proved. Okay, that's one. The other two, yeah. Yes. So this is 3rd November, yeah. Next one, yes, this one. So that is number 1. Number 2, actually only one of these two, not any one of the following 2 questions. That's it. And number 2, because this is important, lambda is an eigenvalue. If suppose lambda is an eigenvalue, of A, and suppose X is the corresponding eigenvector, is a corresponding eigenvector, show that 1 upon lambda is an eigenvalue I should write is an eigenvalue of an invertible matrix, naturally. Eigenvalue of an invertible matrix. Of an invertible matrix A, and X is corresponding eigenvector. X is corresponding eigenvector. Here it is. So then 1 upon lambda is an eigenvalue of A inverse, and X is the corresponding eigenvector. being eigenvector. Okay, let's do this. So you have AX is lambda X. So this implies A inverse AX is A inverse lambda X. So that implies A inverse A X is A inverse lambda X. So that implies IX is lambda is a scalar, goes out, lambda A inverse X. That implies X okay. So do it this way, X is equal to lambda A inverse X. So that gives me 1 upon lambda X is A inverse X. Hence we have, and hence that is A inverse X is 1 upon lambda X. That implies 1 upon lambda is an eigenvalue of A inverse, and X is the corresponding eigenvector. That is it. So tomorrow I will. So there you go. I mean, we have discussed this. We have discussed this. The fun questions, as I said, I will discuss one problem. So how many questions I'm going to review tomorrow? I will tell you. I will review
Professor,
one.
Can you scroll down a little?
Yeah, I will. Just a minute, I will. 1, 2. This I have finished now. I will remind you about orthogonal matrix 3, and 4. So I will discuss 5 problems tomorrow again. Is this okay? Okay, that's basically it. So I will do two Gram-Schmidt orthogonalization process problems tomorrow. So one of them will be the exam 2 question. One of them will be the exam 2 question and the other. So 2 types. Again, I will discuss 2 tomorrow. And one eigenvalues, eigenvectors problem. I will do the exam 2 problem. So you can see exam 2 problem. So that will be a good practice. I will not ask diagonalization. So, and then I will remind you about orthogonal matrix. Yeah, and linear transformation we don't have to discuss. We have already discussed. That's it. I think that's very good. So 8 problems, 8 questions on the final exam. That would be a good one. Okay.
Yeah, they look good.
Yeah, I think I will discuss some just mixed problems tomorrow. So that so that's the review. So tomorrow is the review. So tomorrow is the review. Review for final exam. Friday, December 11, 1:40 p.m. Okay, that's enough. Let's stop today's discussion. I'm going to send you this notes today, right now, actually. Yeah, John Pulley, what was your question? John Pulley, what was your question?
I'm asking if you're gonna how you call curve the second exam or no.
Curve.
Yeah.
Yeah, and the second example will be curve, like this. Anything less than 90 is an F. Anything less than 80 is an F minus.
I knew you would say something like that.
What curve? You don't have to worry about all that. Okay, so we will discuss the two problems of the exam. So that will be a good review also. Okay,
Okay, thank you, Professor. See you tomorrow.
see all of you tomorrow.
So is
Definitely.
there any extra points? Is
Huh?
there any extra points for doing the evaluation?
Evaluation? No, there are 4 questions, all 25 points each.
Oh,
But there will be a lot of from the partial credit. Don't worry about all that. Focus on your final exam.
Okay, Professor. Thank you, Professor.
Focus on your final exam.